So if you watched my video on Jamaica's geology, you might remember me saying that I'm not particularly fond of when people refer to Jamaica as just a limestone island. I much prefer people say Jamaica is mostly limestone or Jamaica is predominantly limestone. And there's a reason for that. While limestone does dominate large parts of the island, there are significant areas that are not limestone at all. In fact, one of the clearest pieces of evidence is our drainage system. Jamaica has extensive surface drainage, rivers with multiple tributaries, and that's not what you'd expect in a purely limestone landscape. Limestone tends to promote underground drainage, not the kind of surface networks we see across the island. But anyway, I digress. What I really want to talk about today is something much deeper, something that helps to explain those non-limestone regions. I'm talking about what researchers refer to as the Caribbean Large Igneous Provinces, or CLIP. So stick with me as we take a closer look at the parts of Jamaica that are, not really spoken about by most people, the parts that are not limestone. So before we get into the Caribbean Large Igneous Province, we need to take a step back and talk about large igneous provinces in general. So LIP before CLIP. Large igneous provinces, or LIPs, are massive accumulations of igneous rock, typically mafic or mafic, meaning they're rich in iron and magnesium, and they're also dark in color. And these aren't formed through normal seafloor spreading either. Instead, they're associated with mantle plumes, huge upwellings of magma rising from deep within the earth, and episodes of intense, short-lived volcanic activity. And importantly, LIPs have been linked to major environmental changes throughout Earth's history. So, what exactly is the Caribbean Large Igneous Province, or CLIP? Well, it's one of those LIPs, but simply it's a massive region of volcanic rock that formed during the Cretaceous period, when enormous volumes of magma rose from deep within the earth and spread over a wide area. This wasn't a single volcano, it was more like the earth opening up and lava flooding across entire regions, eventually cooling and solidifying into thick layers of rock. And parts of Jamaica are built on that foundation. So while the island is mostly limestone at the surface, the clip represents the older sort of volcanic roots of Jamaica, the reasons these non-limestone areas exist in the first place. Now, these rocks aren't just buried beneath the ground, they actually outcrop at the surface, particularly in and around the Blue Mountains. In fact, Professor Simon Mitchell discussed this in a 2022 paper entitled Out of Many One, The Story of Jamaica's Geology, which I'll link in the description. In that paper, he explains that Cretaceous rocks in Jamaica are associated with both island arc systems and also the volcanic origin of the clip, particularly in eastern Jamaica and in areas known as inliers. He describes the eastern Blue Mountains from Bath in the south to Port Antonio in the north as containing a suite of igneous rocks from the Cretaceous. These rocks carry chemical signatures that point to the formation of a mantle plume originating deep within the earth near the core mantle boundary. What's fascinating is that these rocks aren't isolated to Jamaica. They're part of a much larger system, the Caribbean Lip, which also underlies parts of the Caribbean Sea, Haiti, and even extending to Costa Rica. Even more interesting, this entire system likely originated near what is now the Galapagos hotspot in the Pacific Ocean. before being transported and then placed between the North American and South American plates to form the Caribbean we see today. And the clip shows up again and again in the scientific literature, which is exactly what we'll dive into in the next segment. So in 2022, Professor Simon Mitchell, along with Andrew Kerr and Alan Hastie, published a paper in the journal Results in Geochemistry. In it, they examine the Cretaceous cliff rocks in Jamaica, presenting a new geochemical dataset for the island. One of the key findings is that there are noticeable differences in the geochemical signatures of the cliff rocks, particularly those on the southern flanks of the Blue Mountains. The authors distinguish between what they refer to as the main clip and the extended clip, suggesting that even within the large igneous province, there is some internal variation with the geochemistry, so it's not completely uniform. This 2022 study also builds on earlier work, including a 2008 paper that it helps to corroborate. So I went digging a bit and I found it. That study, published in Lithos by Hastie and colleagues, is titled Geochemistry and Petrogenesis of Cretaceous Oceanic Plateau Lavas in Eastern Jamaica. In that paper, the authors identify the Bath Dunrobin Formation as a fragment of the clip. They use isotopic systems such as strontium, neodymium, lead, and hafnium to trace the lavas back to a mantle plume source that appears to be enriched by recycled oceanic crust. I also came across another study while preparing for this video, this time published in Nature Communications. It isn't specific to Jamaica, but I think it's important for broader regional context. This paper uses geodynamic modeling to challenge some of the traditional ideas about the clip. It suggests that the clip was triggered by a mantle plume, but one that was effectively brought toward the surface by major reorganization of subduction zones. What's interesting is that, like in all science, these ideas are constantly being tested and debated. Researchers don't always agree, and the models continue to evolve. But the key takeaway I want a layperson watching this video to understand is simple. Jamaica has a clear volcanic history, and those volcanic rocks are exposed in parts of the island today. The clip is a major part of the story, but it's not the only one. Volcanic rocks also appear in island arc systems preserved in Jamaica's Cretaceous inliers, adding even more complexity to the island's geological foundation. So I hope this video gives a clearer sense of why I'm not a fan of the term limestone island when referring to Jamaica. I've heard other scientists outside of geology, of course, use the term as well, and I have also seen it show up in simplified explanations when the physical geography is being taught to younger students who are not yet in university. But while it's convenient, I think it can sometimes be an oversimplification, and in fact, Limestone Island can give a misleading impression of what Jamaican landscape actually is. It oversimplifies the geology and in a way strips away its much more complex volcanic history. Yes, large parts of the island are limestone, most of it anyway, but the non-limestone areas are just as important. They include other sedimentary units like shale and alluvium, but also significant igneous rocks at the surface, including basalts and granodiorites. So Jamaica's geology is far more diverse than the single label of Limestone Island suggests. Anyway, thank you for watching, and I'll see you in the next one.